Okay, another important thing is to know how can you tell if an object is speeding up or slowing down? Okay, so we have a rule that if velocity and acceleration have the same sign, then the object's going to be speeding up. If they have opposite signs, the object is going to be slowing down. Okay, so here we can see that if they're both positive, the object's speed is increasing. If they're both negative, the object's speed is also increasing. Now, if those signs are opposite, the object's speed is going to be decreasing. And you can just memorize this, but I like it if you can understand why. Why is that happening? Okay, so normally I do a little example in class, but I want you to think about a person, and we'll have their hair blowing in the wind, and that this person is walking to the right. Okay, so if they're going to the right, then their velocity is greater than zero, because we said anytime velocity is greater than zero, they're going to the right, less than zero, they're going to the left. Okay, so I want you to think about that another person comes up and pushes this person in the back. Okay, so if they're walking to the right and they get a little push, and that push is pushing them that way, they're going to move a little bit faster. Okay, and that push would be acceleration. Okay, you could also think of an airplane. If an airplane is moving to the right and the wind comes up from behind it and pushes it in the direction it's going, it's going to go faster. Okay, so let's put here that we have a push in the direction person is traveling, they will speed up. That's supposed to be a comma. Okay, so now I want you to think about the same thing would go if they were headed towards the left, which would mean velocity is less than zero. Acceleration is going to the left, which means it would be less than zero. So even if they were both going left, they would still start going faster. Okay, so now let's say we've got our person and they're jogging, hair is blowing in the wind, and they're coming this way. And a person comes up to them and pushes them this way. So velocity is greater than zero. And let's have acceleration be less than zero. Or, again, think of an airplane. Airplane's flying this way. The wind starts pushing the airplane back this way. And maybe it's still going forward, but it's going to be slowing it down. Okay, so again, push in the opposite direction that the person is going. Will slow the person down. Okay, so I find that if you think about it as opposed to memorizing it, it's easier. Okay, so let's look at a little example. We got a model rocket. It's launched vertically from the ground with an initial velocity of 114 feet per second. Okay, so remember our position function. There's its initial velocity. Its original height was 0 because it was from the ground. So this is giving us the position, the height of the rocket over time. Okay, find the velocity. That means instantaneous and speed of the rocket at t equals 5. All right, well, the velocity is equal to the derivative of the position function. So that's going to be negative 32t. plus 114. Okay, that's our formula. So I'm going to show the velocity at 5 seconds is negative 37. And again, even if I'm using a calculator, I need to show that step to say, where did that number come from? Okay, so it's going to be negative 46 feet per second. Remember that this formula is always in feet per second. Okay, so now it wants the velocity. Well, there's that. And it wants the speed, which is just the absolute value of the velocity. So it is 46 feet per second. Okay, and I want you to notice how everything's labeled very, nicely. I want your work labeled like that, okay? I shouldn't have just random answers all over the place. Okay, so now we want to know, is the rocket speeding up or is it slowing down at that time? Well, I know that the velocity is negative, so I have to figure out, well, what's the acceleration? Is it negative or is it positive? So acceleration is the derivative of velocity. Okay, so acceleration is the derivative of velocity. Or you could think about that acceleration is the second derivative of position. Okay, well, the derivative, if this was velocity right here, the derivative of velocity would be negative 32. Okay, so A of 5 is the same as the derivative of velocity at 5. And it's just going to be constant there at negative 32. Okay, and we're going to look at, okay, so what was velocity at 5? Velocity at 5 was negative 46. Okay, so I don't have to worry about units or anything like that because right now they just want to know if it's speeding up or slowing down. Okay, explain how you know. Whenever you see explain in calculus, that means show the math. Okay, I'm showing the math. And then I'm going to explain, and I'm going to say since velocity and acceleration have the same sign, which means they are both negative, the rocket is speeding up. Okay, and you want to make sure that you're copying this down, and I think some of you guys got caught on that last quiz of being like, oh, I don't need to copy that, I know the answer. Well, the answer is one thing, but making sure that you're properly justifying that answer is something different. Okay, so now we want the maximum height that the rocket is going to rise. Okay, well, max height would be when it's going up and coming down. Okay, that's when the slope of our secant line is 0. Now that's only going to give us the time, but once we know how long it's going to be, then we can figure out its max height. Okay, so we want to know when is the velocity equal to 0. Now we already proved how we got velocity up here, so we don't have to prove that again. So I just want when is negative 32t plus 114 equal to 0. And yes, you do need to show that. So t is going to be 114 over 32, which is approximately 3.5625. Notice I put 4 decimals. calculus, AP calculus, they want 4 decimals in every answer of anything that's not an exact answer. Okay, so always go to 4 decimals. Okay, so this didn't answer the question what. This answered the question when. So I know it's going to happen after that many seconds. So I got to figure out, okay, well, how high was it after those many seconds? Okay, so the maximum height then is equal to S of 114. Now, when I put this on my calculator, I prefer to put in the 114 over 32 because that's going to be more accurate. And I got to show, okay, well, what does that look like? Where are you putting this in? So I'm saying that is equal to negative 16 times 114 over 32 squared plus 114 times 114. Okay, so I do have to prove where, how I figured that out. Of course, I'm going to go to a calculator, and that's going to be approximately 203.0625 feet. Okay, so that's my answer, but I got to have all of this stuff to prove how I got it. Okay, and now we see the speed of the rocket when it hits the ground. So that's going to be when the position is 0. Okay, so let's figure out when that is. Okay, well, negative 16 t squared plus 114 t equals 0. I'm going to factor out a negative 2t, and that's going to give me 8t minus 57. T is either 0 or t is 57/8. Okay, so notice that 0, well, that's when it took off. Okay, so this is when it hits the ground. Okay, so again, I didn't answer the question. It wants to know what is the speed. Well, the speed is the absolute value of the velocity when it hit the ground. Okay, so speed is the absolute value of the velocity at 57/8. Okay, so that is the absolute value of negative 32 times 57/8 plus 114. And there is my answer. Okay, so again, in order to justify that answer, maybe I'll put a second on here. I would want to do or show all of that stuff. Okay, that's it.